Hello, we are here today to talk about the Frictionless EV charging station, which is a senior design project that is sponsored by Duke Energy.
The objective of this Duke Friction Senior Design project is to design a frictionless charging station. Frictionless charging station will minimize the user interaction, which has been identified by Duke as a barrier for entry into the adoption of electric vehicles. The charging station will need to process transactional information to correctly bill the party that is charging their vehicle. Project specifications include the EV charging station operating as a level 2 charger, being able to automatically activate at low power usage hours, meaning at nighttime, and it will include a manual override for more immediate charging options. The system itself will include an RFID scanner and tags to identify the user and be able to send the correct bill to the correct person. And we'll also be able to recruit energy usage that also sends the correct bill.
The housing design, we made a breakaway system using share pins. This is designed to have the unit break away from the base. We use a Chevrolet Volt as a model going at 10 miles per hour because this is expected to be in a driveway. For the ease of use, all connections are made at the hip level for increased accessibility. Materials were all chosen to withstand weather conditions.
The electrical design, we're using the OpenEVSE starting kit as a base due to its ability to be openly modified. And another reason is due to its use of relays and the temperature sensors, as well as the ground fault system for protection purposes, as well as including diodes that are properly biased the circuit in the correct direction to prevent backwards flow of current. For this modification, we'll be utilizing the transmission receiver pins that we hooked up to the Arduino Mega that will be centered as the transmission receiver module. This module will be connected into the Raspberry Pi module, which will be used as user interface, and as well as be connected into the LTE connection shield, which we'll use to send the information that will be stored on the central server.
For the software design, we chose the OpenEVSE kit for the firmware that will be based around the source codes for the software and hardware provided. We plan on adding our own Wi-Fi module and LTE system. We plan on having an RFID sticker attached inside of the car, and the RFID will be used to identify and bill the users.
Our future plans will consist of ordering the components, assembly, and testing. Failure during this time will be found out with the compatibility of Raspberry Pi and Arduino. Other plans will be to continue analyzing the base code of OpenEVSE in order to understand how to modify the code properly. Thank you for taking the time to read this, and have a good day.